In this video, I want to show you the process for factoring an algebraic expression by grouping. And grouping is going to come in really handy when we start factoring quadratic trinomials using the AC method, which is another video, or when we're starting to factor expressions with 4 or even more terms. Okay, so I want to talk first about the most important part of grouping, and this is a step that you have in the middle of the process. Well, it looks like this expression has two terms. Our first term is the product of 5x and x minus 3. And the second term is again a product, but the product of 4 and x minus 3. So recall from factoring expressions using the greatest common factor is that we can take the greatest common factor and we can divide it out of both the terms and kind of put it out front as a backwards distributive property, if you will. Well, it looks like both of these terms contain the x minus 3. So I'm going to factor out that x minus 3 and put it as its own quantity out front. And what's left is this 5x and this plus 4, and that will go right here. Okay, so this is kind of what that factorization looks like. So the most important part of grouping is that you can factor out a greatest common factor that happens to be a binomial or even a trinomial. It doesn't have to be a single number or a single variable. So for this first example in grouping, we have the algebraic expression 4m cubed minus 12m squared plus 3m minus 9. So the way grouping is going to work is we're going to break this up instead of one expression with 4 terms, we're going to break it up into 2 expressions with 2 terms each. Okay, so what's the greatest common factor of this first pair? Well, it looks like 4 and then m squared. So when I divide out that 4m squared, it looks like what I have left is m minus 3. All right, we'll kind of ignore that for a second. Let's come over here to the second pair. What's the greatest common factor here? Well, it looks like a positive 3, so I'll put plus 3. And what's left over when I divide this positive 3 out? Well, m minus 3. So here we are looking at an expression like we saw at the very beginning of the video. I have this m minus 3 that's going to be the same factor in both of these terms. So what I can do is go ahead and factor out that m minus 3. And then what's left over is this 4m squared and the positive 3. So here is the final factorization then for this algebraic expression with 4 terms. And I will say a quick note here, sometimes these factors can be factored again. In this case, we can't do any more, so this is the final answer. In this next example, we see we have another expression with 4 terms. So what we're going to do is go ahead and divide it up again into the first 2 terms and the last 2 terms. So what's the greatest common factor here of this first pair? Well, it looks like they both have a 3 and an n squared will be the greatest common factor. So what's left over then looks like it's going to be 2n, and then right here some students struggle with this. So the 3n squared, that's this term, happen to actually be the greatest common factor as well. So some students will skip over that, close their parentheses, and move on. But we can't do that. We're dividing the 3n squared out of both of these terms, so when we do it out of here, we actually have a minus 1 that we need to put there. Because if you were to redistribute this, you would see it would need to look like this. So just because one of the terms happen to be the greatest common factor, don't leave it out. We need to put this minus 1 here. And again, it's minus because of the subtraction right there. Okay, let's move on to the second pair. The second pair is negative 8n plus 4. And it looks like I'm leading with a minus here, so I want to factor that negative out. And between 8 and 4, it looks like 4 will be the greatest common factor. So what I'm left with when I divide a negative 4 out of these 2 terms is 2n minus 1. So again, you'll notice these leftovers here are the same. So I'm going to go ahead and factor these leftovers out as the greatest common factor. So 2n minus 1. And the leftovers then will be 3n squared minus 4. So here's the factorization using grouping for this algebraic expression with 4 terms. In this final algebraic expression that I would like to factor, I see I have 4 terms again, and it looks like I actually have a greatest common factor that I can pull from all 4 of these terms before I ever get started. So between the numbers 30, 24, 15, and 12, it looks like I can take a 3 out. And it looks like all the terms have y's, and the smallest one is y to the first, so let's go ahead and factor out 3y from all these. So when I do that, it looks like I'm left with 10y cubed plus 8y squared minus 5y minus 4. Okie dokie. So here we have our 4 terms. Let's go ahead and do grouping again. So we're going to group them into the first set and the second set. So out of the first pair here, it looks like I have a 2y squared I can pull out. And what I'm left with, it looks like, is 5y plus 4. Okay, so how am I going to write this with this 3y in here? Well, I'm going to put big brackets around all this and keep bringing my greatest common factor down. Okay, now the greatest common factor between these two, well, it leads with a negative, so I know I want to pull a negative out. But as far as 5y and 4 is concerned, it looks like the greatest common factor is just 1. So whenever I divide a negative 1 out of both of those, I'll have 5y plus 4. And again, that's really nice because these leftovers are the same. So what I can do is go ahead and factor those leftovers out. So 5y plus 4. And then those greatest common factors that I pulled out initially, 2y squared minus 1, looks like that. But of course, we have this greatest common factor at the beginning, so he needs to come along for the ride. We can't just forget about him. So the first thing we did was we factored out the greatest common factor for all the terms, and then we broke them up into pairs and used grouping. So here's what you have for your final fully factored form of this algebraic expression. And we've done all this by grouping.